Hello, today we are going to create this analysis of a pendulum, and we are going to say it's a simulation. As you can see, the dampens. This pendulum has a damper. Basically, we have defined the friction. We are going to define this, and we are going to say we're going to measure the movement of this pendulum. That we're going to measure and see the graph. You can see how it is oscillating, then dampens because we have defined friction. We're going to define friction here. I'm going to right click here, define here. You can see dynamic properties. We have defined friction, but if you don't define friction, this will oscillate without stopping. Let's see how we can perform this analysis. I'm going to close out here, don't save. And one thing I'm going is I'm going these two parts. Let me just open them. This is the first part. This is the sketch. If you go to the front view, these are the dimensions, and the most important dimension is this one, 100, because our pendulum will be attached onto this point here. Once you create that, you just extrude up to 50. Then it is a symmetry. Then for the other part, let me go the other part, pendulum. We have this, the first one here, 100, and extrude it at 75. That distance doesn't matter so much. Then I have this plane. We can use you can use this plane, use this middle plane here instead of adding another datum. Basically, we are using a middle plane. You can see this one is a plane that is between this surface and this surface here. Then sketch. Let's see the sketch of the ball here. Ensure create a ball of 50, 350 here. This is 350. This height. Yes. Then on the same plane, on this plane here, you sketch a string. You can see I have just this length, this line here, from this point to this point to present my string. If you want to assign material, you can assign material of steel, though in this case the pendulum oscillation is not dependent on the weight, on the mass. Yeah, therefore you don't need to define the material properties. You have to ensure that when you create this sketch here, you add this point. You see this point, so that you can get this axis. Okay, now if you go back now to assembly, let me look for the pendulum mechanism. This part is fixed. If you go to this part, insert this part, and you can see I fix the part. Then for the pendulum here, I have defined pin connection. Let me just redefine again. Okay, once you select the connection type, you have to use pin allows you to rotate, and I want this part here. Let me just move it. You see this part, let me just move it out. I want this section here, the highlighted section, to rotate inside this surface using a pin connection. Therefore, you need not to select axis. The component axis is this axis here, to rotate onto this axis. You can see once I define this one, you can see now this axis and this axis are coincident, but you see the connection is not defined because now this one can translate. You see, they can move like this. If I go this front view, it can also move, can only move like this, but you see they can't move. The white means they can't move on this direction. At the same time, we can rotate. We only need this rotation, but we don't need this movement. Therefore, again, if you activate the planes, let me just move this a little bit. I want now to, for the translation, I want this plane, and this plane to be coincident like that, because for me I'm only interested by rotation. Then say okay, then head planes, then you go front. Okay, if you now try to move this part here, it can move. This is what I need. This is what I'm going to do analysis to simulate this movement. Therefore, let me just move it again. Let me just cancel, cross, move again, and I want to define my starting point. Once my pendulum will always start at this point, therefore I want to call this one here initial point, like that, then close, so that in case I move it like that, I can go to initial and activate, close. Therefore it will always start this point, then oscillate. Once you define the pendulum, you go to now applications, you go to mechanism, and first thing we need to define here is gravity, because now this one is going to oscillate under the influence of the gravity. Select gravity. You can see the arrow is pointing downwards because we have used negative y. If you use positive 1 here, the arrow points upward. Therefore negative defines the direction, because gravity is a vector quantity. You need to define direction. Okay, therefore the gravity is defined. Then we need to define, I need to define, next is I want to define the motor. And for you to define the motor mechanism, usually use the servo motor. But remember, that is in case you want to define the motor. You just select here and select whatever you want to define. If you want this one to keep rotating. But in this analysis, we want this ball to rotate under the influence of gravity. Hence, you only need gravity. You don't need to define anything else here. Gravity, direction, and the initial state. If I go now to the mechanism analysis, the type of analysis is dynamic, because we have now the movement is under the influence of a force, that is the force of gravity. Whenever you are concerned, whenever the movement of a certain part or component is caused by the force, that is the dynamic analysis. But the kinematic is just the direction, and just the motion, velocity and acceleration. For now it's a dynamic analysis. We don't have the motor. For the dynamic analysis, we don't need to define the item giving us the motion, because we have the gravity. For now we are going to start with the gravity. Enable gravity. We will enable friction later. Let's first see the analysis without the friction here. Then if you go back to the references, I just want to make a small motion. For the duration, you can use, let's use 10 seconds. That's fine, with a frame rate of 10. And yeah, let's just use the current one here, like the current position, and say run. Then if you say okay, if you go to playback, you can now play and see let's see, let's play here and increase the speed. You can see now the pendulum is oscillating under the influence of the gravity, but we don't have the damper. If I go to the, let me close this, let me go to measure. I want to measure position of a point. I want to measure position for certain point, and you can have a point at the center of this pendulum here. You have a point at the center. I will show you how to create this point at the center like that. Then for the component, I want to use X component, this X direction. I want to see how this point is moving along the X direction. You can select either magnitude if or whatever the component you need. For me, I want to see X direction here. I want to see OK. Therefore, I want to see the analysis definition 2 and then plot. You can see now the X direction is oscillating up down. This is the maximum point reached. This is the minimum point. You can see the motion is simple harmonic. We don't have the damping. Okay, if you go back to this measure here, edit, if you go to the Y component, okay, then graph this. You can see same graph, same case. Let's see Z component, that is normal to the screen. Let's see if you can get anything. You can see we are not oscillating normal to the screen. It is constant. Yeah, therefore that's how we can define all these components. You can also try magnitude. You can see same thing happens, similar thing. Therefore, if I want this now the pendulum to dampen with time because of the maybe friction. Remember this section is rotating. You just select this rotary motion for the pin. Select the first one here, edit definition or Control E. I want us to define dynamic properties, and we need to define friction. We have two types of friction, static friction and kinematic friction. For the static, let's call it 0.02, but for the dynamic 0.01. Static is usually higher than kinematic. This one is when the friction when this part is in motion is 0.01. Therefore, for the radius, at which point is this friction being experienced, it has 50. Remember we used 100. Therefore, the radius of this part is 50. Put 50 there. Go back to analysis. It is this analysis 2. And if you go to the external load, enable all friction, then say run. Before I do run here, okay, let me just go back to the front. I want to drag this part and have, basically I want this to be my starting point. Remember the snapshot we created for the initial starting point to be there. Then go now to the analysis here, copy, edit, enable friction, same, then say run. Yes, you see as the time progresses the motion reduces for the pendulum until it stops. Yeah, let's see, maybe the duration wasn't enough to stop. Let's go with the 20 and run again. We need to stop this first because we need to redefine again the starting point, the initial point, like that. Go back to analysis and you go to the ensure you have enable all friction, then run again, and now put 20 here, 20 seconds, then run. Yes, will take some time like that until it dampens, then it will stop because of the friction. Yeah, then say okay. If you go now to the playback, let's see. Let's now play. Let's add speed. You can say to play. It oscillates, dampens because of the friction until it stops. It stops at vertical position. If if you want to see now the motion, you can go to point one analysis and just graph this. You can see it starts to dampen until it stops at this point here. Okay, if you vary this friction here, if you want to reduce if you let me just graph this again and see, if you want to reduce this time taken until this pendulum stops, you have to increase the value of friction here. If I go back here, can increase this value, dynamic properties, until you get the desired results. That's how you can perform simple pendulum analysis. And I said I'll show you how to put this point at the center. Let me just activate this part. Let me just open here. You can see if you want to put a point at the middle, you can just go to the point here, then select this surface. References, we have three references: on, offset, or center. Select center. Once you select center, say okay, you're going to get this point exactly at the center. But for now, I don't need it because I already have my point that is I'm using to take the measurements. Then yeah, I can go to front. Yeah, that's how you can perform a simple analysis of a pendulum mechanism. Thank you, and share, like, and comment. See you in the next video.